Let's explore the fundamentals of computer memory systems. We'll be covering random access memory, often called RAM, read-only memory, known as ROM, and how memory is organized within a computer. Memory is the storage component of a computer system. It holds the data and instructions that the central processing unit, or CPU, needs to perform tasks. Think of it as a temporary workspace where the computer keeps everything it's actively working on. The CPU interacts with the memory to read and write the data and instructions. Let's dive into RAM, which stands for Random Access Memory. RAM is a type of volatile memory, meaning it loses its data when the power is turned off. It provides fast access to data, and the CPU can both read from and write to RAM. RAM is also known as direct access memory, because any memory location can be accessed directly. There are mainly two types of RAM. One is static random access memory, or SRAM. SRAM uses flip-flops to store each bit, resulting in faster access times but also higher costs. It's often used for cache memory and doesn't require constant refreshing. Then there's dynamic random access memory, or DRAM. DRAM uses capacitors to store each bit, which leads to slower access times but lower costs. DRAM is commonly used as main memory in computers, but it needs to be refreshed periodically to maintain the stored data. Now let's explore ROM, which stands for read-only memory. ROM is a type of non-volatile memory, meaning it retains its data even when the power is off. Unlike RAM, ROM is primarily read-only, meaning data is typically written to it once and then only read from. ROM is commonly used to store firmware, which are essential instructions for starting and operating a device. Because ROM retains data without power, it's ideal for storing critical system information. There are several types of ROM. First, there is programmable read-only memory, or PROM. PROM can be programmed once by the user with special equipment. Then we have erasable programmable read-only memory, or EPROM. EPROM can be erased using ultraviolet light and then reprogrammed multiple times. Electrically erasable programmable read-only memory, or EPROM, can be erased and programmed electrically without needing to be removed from the device. Finally, there is flash memory, which is a high-speed EPROM used in USB drives and solid-state drives, also known as SSDs. Now let's discuss how memory is organized within a computer system. The CPU communicates with memory through several buses. There's the address bus, which specifies the memory location to be accessed. The data bus, which transfers the actual data between the CPU and memory. And the control bus, which sends control signals to coordinate memory operations. Each memory location has a unique address, allowing the CPU to access specific data. This organized structure enables efficient memory access and management. The memory hierarchy organizes different types of memory based on their speed, size, and cost. At the top, we have CPU registers, which are the fastest and smallest memory components with the highest cost. Next is cache memory, which offers very fast access and is still relatively small and expensive. Then comes main memory, providing a moderate balance between speed, size, and cost. Finally, we have secondary storage, which is the slowest but largest and least expensive type of memory. As you move down the hierarchy, speed decreases and cost decreases, but the storage capacity increases. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.